Greetings, colleagues. My name is Paul DiGiacomo. I'm the director of the Satellite Oceanography and Climatology Division in the NOAA Center for Satellite Applications and Research. And I'm very happy to have the invitation to join you today and speak to you on this very important topic. My presentation today will be on coastal zone observations in support of marine spatial planning. So we're all aware of the importance of coastal zones from both an environmental perspective as well as a socio-economic perspective. These are very dynamic, very productive, and very important regions for so many different reasons. And for that reason, we're trying to focus on enhancing what we're calling the coastal zone value chain, going from observations to data to derived products to information that's actionable for users. And along those lines, I'm going to be speaking to you today on two different activities that we have. First is the Committee on Earth Observation Satellites, CEOS for short, and the CEOS Coastal Observations Applications, Services, and Tools, COAST team. And you see the link there, and we will be having a public data portal launch in spring of 2023. And you'll hear some more details about that momentarily. And I'll also be speaking to you about the NOAA Coast Watch program, which is run out of my division in NOAA and supports not just NOAA users, but users around the world for satellite data and derived products for a variety of different applications. So we'll start off by speaking a little bit more about CEOS Coast. Again, that's the Coastal Observations, Applications, Services, and Tools team. And CEOS Coast is an activity. CEOS in particular, for those that are not aware, is an international organization bringing together all the Earth observing space agencies, satellite agencies, of which NOAA is one. And CEOS stood up an activity which I co-chair along with Dr. Rashmi Sharma from the Indian Space Research Organization. COAST focuses on the coastal zone, and particularly the land-sea interface, but also coupled with that human component, the people interface. And as noted, so we're leveraging Earth observation data, which is not just satellite, but also in situ measurements to address a variety of very important coastal problems addressing society. And we'll discuss those more in a moment. But it's bringing the data providers, again, with the coastal users and stakeholders, and particularly in a process that's co-design and co-development. And we really listen to and understand the users and what their needs are, which can include marine spatial planning and other activities, and bring in not just environmental science data, but also socioeconomic data as well. And importantly, these data are free and open to all of the public through our application knowledge hub. And also we have different pilot regions that we're focusing on initially, which we'll see momentarily, to leverage some of the activities that are there, but more so, ultimately, this will be focused on coastal zones globally. Next. CEOS Coast has been recognized as a contribution for the United Nations Decade of Ocean Science for Sustainable Development, and we're in the Ocean Decade right now, UN Ocean Decade right now. And CEOS Coast is partnering with many different partners, including Coast Predict, which is focused on coastal forecasting and prediction. A different activity in CEOS called CEOS Coverage, focused more on the basin scale oceans, trying to bring together mutual capabilities of interest and more so a network for capacity building across the globe, particularly for developing nations. As part of CEOS Coast, and as mentioned for CEOS, we have many different space agencies involved. You see some of those here. We are always looking for additional partners and collaborators, not just within CEOS, other space agencies certainly, but any organizations around the world, UN organizations, non-governmental organizations, et cetera. So there's many opportunities for all to participate. So COAST, again, is focused on this very important coastal zone, and particularly as you see here, the interface between the land and the sea. And in that context, COAST is made up of three different components. The first one is we have a sea to land component, which is focused on primarily physical forcing and impacts such as flooding and inundation and erosion. And then there's the reciprocal impacts for the land to sea, which is looking at impacts and responses, more so focusing on biology, ecology, and biogeochemistry. And you see listed on the slides some of the different products that are needed on both sides, the sea to land and the land to sea. But you also see some of the cross-cutting needs, and this is the third component of COAST, and this is the informatics component, which is foundational to all of our science-driven activities. So we need analysis-ready data, we need tools and products and different services to get the data and products out to users, particularly through a web portal. As referenced earlier, ultimately CEOS Coast is intended to support coastal zones globally. But initially, we've identified a subset of high priority, high impact areas, and particularly where there's a lot of different developmental activities underway from space agencies as well as other partners. And you see these are both at the continental scale, which include the Chesapeake Bay in the United States, and that's where I'm located in that area, so based out of Maryland and with our NOAA lab. There's also the Bay of Bengal, and that's a particular interest for our ISRO, Indian Space Research Organization colleagues. We're also interested in the west coast of Africa, and which Blue Planets, GeoBlue Planet recently held a GeoBlue Planet Symposia in Accra, Ghana, which was very successful, and working to partner with stakeholders there between CEOS and GEO and the different partners, building on activities, Digital Earth Africa, work from Geoscience Australia, etc. There's also the Rio de la Plata in South America, which is a very interesting region from a water quality and from sediment loadings and impacts. Those are all at the continental scale, but we're also interested very much in small island nations or large ocean states, as they're sometimes referred to, both in the Caribbean as well as the Pacific. And particularly because, as we're all aware, these are areas that are extremely sensitive to the impacts of climate change, and many of the different problems that we speak about in coastal zones globally are exacerbated in these small island nations. So some of the different areas, the different thematic regions, topics that we're focusing on for CEOS Coast include habitat mapping, both submerged aquatic vegetation, as well as what's at the land-sea interface, and looking at mangroves and salt marshes and regions like that. These are very important from a blue carbon perspective because they positively affect coastal resilience and the ability of coastal zones to weather what's happening with flooding and inundation and sea level rise. And so trying to accurately map and provide information on the health and productivity of these. And these are very important from a nature-based solution to protect the coastline, the shoreline, and the people. I mentioned previously coastal eutrophication. This is an activity where CEOS Coast is actively working with GeoBlue Planet, as well as UN Environment for Sustainable Development Goal 14.1.1, which is focused on coastal eutrophication. And what we did is work with UN Environment to develop satellite-based indicators using chlorophyll as a proxy of phytoplankton biomass as an indicator of nutrient loading into the coastal zone, and looking at anomalies over time and in space for different regions. And you see some of these here. We're looking at different regional exclusive economic zones. And at the bottom of the slide, in particular, some examples off of the Australian coast. And so the power and the utility of the satellite observations is to identify areas where there's changes occurring, and then for local managers to be able to go in and to look more intensively with field-based observations and understand where some of these sources and loadings of nutrients might be coming from, as well as what some of their impacts are in terms of algal blooms, and in particular harmful algal blooms. These are some other examples of CEOS Coast products and attendant applications that we're working on, particularly turbidity products, which is very well captured using satellite ocean color and other optical imagery. And we can look in all those different regions and pilot projects for coast and see where there's areas of high turbidity loading and some of the impacts that might be having on submerged aquatic vegetation, some of the fisheries, the aquaculture, also the introduction of contaminants that might go along with these loadings of turbidity and sediments, including various pollutants and pathogens and other contaminants, and then applying these satellite-based tools, particularly for ocean color data, but we're also utilizing synthetic aperture radar and other satellite-based measurements to do this. On the right of the slide, we're looking at satellite-based observations of bathymetry, particularly in the nearshore coastal zones. And these are examples along the United States and India and other places, again, using ocean color optical measurements as well as synthetic aperture radar. The pairing of the optical measurements and the all-weather microwave synthetic aperture radar are very powerful. They're very complementary at scale, but also to help deal with some of the issues that cloud cover presents quite commonly in coastal zones. And so we can get additional data by using the synthetic aperture radar. Other examples of products and applications being pursued by CIOS Coast include flooding in the coastal zone from different applications. These can be from hurricanes and typhoons, and we're looking at those in the Chesapeake Bay. We're looking at those in the Bay of Bengal, as you see here on the image on the left, and as well as longer term change from sea level rise, et cetera, but particularly to identify those areas of flooding and inundation, and particularly how they're impacting some of the local populations and where some of the regions more commonly affected might be. And then on the right, you see some of the river and other bodies of water that we apply these optical tools, including ocean color data, but at different scales, from 1 kilometer scales all the way down to a few meters. But also we are doing it with synthetic aperture radar observations. So particularly identify those areas susceptible to flooding, to be able to map those in space and time, and to be able to understand some of their environmental and ecological impacts as we've spoken about. So we are also looking at shoreline mapping, and in particular how it's being affected by some of these processes at different time scales, both erosion, coastal erosion that could be associated with storm events and typhoon and hurricane events, as well as that change over the longer term and interannual variability. And we're using higher resolution optical imagery data to do that, data from the Landsat series, from the Sentinel-2 series, from some of the Indian higher resolution optical and other tools that are out there. And this is showing along the coast of Australia to look at the different lines represents the change of the coastline, change of the shoreline over multiple years. And again, the satellite data is a very powerful tool, synoptic, and we can look at all regions across all shorelines and coastal zones across the globe. Finally, so we've given a quick tour of the different data sets to some of the different data products for CIOS Coast and some of the applications. We're also loading those all into what we call the CIOS Coast Application Knowledge Hub, and it's going to have a suite of these different environmental satellite, but also field-based measurements for the different regions I mentioned, the pilot projects, but also we're populating these globally as well. We're looking at event scale, again, things like the hurricanes and typhoons, but we're also looking at some of the long-term time series from buoys, but also from satellite data, and you see some of the examples there. And on the right, there is information about these different events. And this is a little bit different than the standard data portal because, again, as is in the title, it's really focused on, there's a curation. We don't have all products in there. We have a subset of those, particularly ones that are gap-free and level 4 products, as we call them, analyses, to be able to really just look at some of the impacts and more directly support users with their particular applications. And as we like to say, to help shop in the data supermarket. And so again, to access these different coastal data and products through this curated knowledge hub. And again, this is not just satellite data, it's in situ and other environmental data sets, but also a variety of socioeconomic data sets as well, including poverty indicators and other areas that are relevant to the human other topics that are relevant to the human condition. But want to introduce all of you to our NOAA Coast Watch activity. And its full title is actually NOAA Coast Watch, Ocean Watch, Polar Watch. But the Coast Watch program within NOAA, run out of my division, supports, as I noted, not just NOAA users, but users across the United States as well as internationally. And we make many different satellite data products available and support different applications and have different tools for displaying and analyzing data, etc., as well as on the bottom right, you see focusing on different applications such as water quality and ecosystems and oceans and climate. And again, really to help curate and help users find the right data sets that are fit for purpose for their particular needs and applications. And that's the Coast Watch website, and I encourage you all to visit. There's a lot of great information from NOAA sensors, but also from partner data around the world. And this is for satellite oceanography in particular, what I would like to refer to as the golden age. We've done all the transitions from research into operations, and we have routine and sustained continuous measurements of all those different parameters you see there on the right: temperature and ocean color, altimetry for sea surface height, ocean vector winds, synthetic aperture radar, sea ice, salinity, and imagery. And we have multiple sensors from multiple agencies from multiple countries around the world. So we have a wealth of data and products. We're very lucky, and I do think this is the golden age of satellite oceanography, and it's going to be particularly beneficial for marine spatial planning, as well as a variety of other applications. So finally, in terms of marine spatial planning applications, I've given you just two of the many activities and services that are out there with See Us Coast and NOAA Coast Watch. And again, these are all in partnership, particularly See Us Coast with different space agencies and stakeholders, UN Environment and others. But NOAA Coast Watch, again, we very much partner with other agencies and entities across the globe. There's no paywall, there's no credentials, you just need the internet access. So there's a low skill barrier to accessing the information. Again, we also spend quite a bit of effort to help curate data sets to identify for users what's fit for purpose for their different applications. And then in addition to the existing products, we're also very actively working on developing new and improved products of higher spatial and temporal spectral resolution, as well as co-designing and co-developing with coastal managers to find products that better suit their needs. And again, for both of these activities, serving as a trusted data source, multinational, sustainable, and high quality. Just some very important activities that are coming up that are very much of interest to Korea. NOAA Coast Watch, EUMETSAT, and KHOA are offering a day-long free training session in June at the upcoming 3rd International Operational Satellite Oceanography Symposium to be hosted June in 2023. We're very thrilled, very excited to work with our Korean colleagues at KHOA and KMI and different partners, as you see there, as well as with EUMETSAT and NOAA. And we encourage you to participate in that meeting. It's going to be a very productive, exciting, and informative meeting, and we hope that many of you will be able to attend. Thank you for the very kind invitation to speak to all of you today, and I hope that the meeting is very productive and successful. To remind you some of the tools that I've described and the website for the NOAA Coast Watch program, the website for the Operational Satellite Oceanography, the 3rd Symposium, again to be held June 2023 in Busan. And for anyone who's interested in partnering in See Us Coast or any of these other coastal applications, I do very much encourage you to reach out to me at paul.digiacomo@noaa.gov. And again, I want to say thank you. Thank you to all my colleagues. These are activities involving many people, great scientists and users and stakeholders around the world, including many great colleagues from Korea. And so we look forward to hearing from you. And again, wishing you a very successful meeting today. Thank you.